Welcome to Module 3 on Principles and Practices in Pest and Disease Monitoring. In this course, we will embark on an in-depth exploration of the essential principles and practical techniques involved in effectively monitoring pests and diseases within agricultural environments. We will delve into the importance of proactive monitoring, which plays a critical role in safeguarding our crops from potential threats. Understanding the interactions between crops and pests is vital for successful agricultural practices. Throughout this module, we'll highlight various monitoring methods that support integrated pest management strategies, ensuring a sustainable approach to pest control. By the end of this module, you will understand the importance of pest monitoring. You'll recognize its critical role in effective pest management and how it impacts the maintenance of healthy crops while reducing economic losses. Next, we will focus on identifying key pests and their behaviors. You will gain knowledge of common agricultural pests, their life cycles, and how they specifically interact with and affect your crop plants. Moving on, we will delve into how to develop monitoring techniques. This will involve learning various methods and tools that allow you to accurately detect, identify, and track pest populations in the field. Lastly, we will explore how to interpret monitoring data. You will acquire essential skills to analyze this data, understand pest population dynamics, and make informed decisions regarding intervention strategies. Introduction to pest monitoring. In this section, we will explore the fundamental aspects of pest monitoring, starting with its definition. Pest monitoring is defined as the systematic observation, detection, and documentation of pest populations within agricultural systems. This practice is a crucial component of integrated pest management, commonly referred to as IPM programs. Now, let's discuss the importance of monitoring. Effective pest monitoring empowers growers to make informed decisions regarding when and how to implement control measures. This process not only optimizes resources but also minimizes the environmental impact associated with pesticide use. Lastly, we will cover the primary goals of pest monitoring. These goals include detecting the presence and abundance of pests, identifying the underlying causes of pest outbreaks, and tracking the effectiveness of various control strategies over time. Understanding crop pest interactions. Pest preferences. Different pests are attracted to and thrive on specific crop plants. This attraction is largely based on their nutritional requirements and habitat preferences, making it essential for growers to recognize which pests may be drawn to their crops. Next, neighboring farms. Pests can easily move between adjacent farms, which underscores the importance of coordinated monitoring and management efforts across regions. This collective approach can significantly enhance pest management strategies. Seasonal patterns in pest populations. These populations often exhibit distinct seasonal activity patterns, influenced by environmental factors such as temperature, moisture, and the availability of host plants. Understanding these patterns is crucial for anticipating pest outbreaks. Grasping these interactions can help significantly with pest management. When dealing with pest monitoring, it is important to consider early detection. Prompt identification of pest presence is essential, as it allows for timely intervention and can prevent significant economic losses. Early action can make a significant difference in pest management outcomes. Population monitoring. Tracking pest population dynamics helps determine the appropriate timing and intensity of control measures. Understanding pest populations allows for more informed decisions on when to act. Damage assessment. Monitoring the crop damage caused by pests guides decision-making regarding the need for interventions and assesses the effectiveness of existing control strategies. This ensures that resources are allocated efficiently. Targeted interventions are crucial. Precise monitoring data enables the targeted application of control methods, which minimizes environmental impact while maximizing pest control efficiency. This approach promotes sustainable agricultural practices. Looking at pest monitoring methods, it is important to discuss visual inspection. This method involves regular and systematic observation of plants to detect the presence of pests, assess their damage, and identify any signs of infestation. Regular checks are essential for early detection. Trapping. This involves the use of various types of traps, such as pheromone traps, sticky traps, and pitfall traps. These traps help capture and monitor pest populations effectively, providing insights into pest activity levels. Remote sensing. This advanced method utilizes aerial or satellite imagery, along with sensor technology, to detect and map the spatial distribution of pests. Remote sensing can provide a broader perspective on pest populations across large areas. Sampling. This technique includes collecting and analyzing plant parts, soil, or other materials to estimate pest abundance and understand population dynamics. Sampling is crucial for assessing pest pressure and planning management actions. And lastly, remote sensing. This advanced method utilizes aerial or satellite imagery, along with sensor technology, to detect and map the spatial distribution of pests. Remote sensing can provide a broader perspective on pest populations across large areas. Interpreting monitoring data. In this section, we will cover how to interpret monitoring data effectively. Understanding this data is vital for making informed pest management decisions. Pest identification. Accurate identification of pest species is the foundation for effective monitoring and management. Knowing precisely what pests are present in your fields allows you to tailor your management strategies accordingly. Population dynamics. Analyzing trends in pest abundance, life stages, and spatial distribution helps predict future outbreaks. This understanding enables you to anticipate pest pressure and respond proactively. Finally, economic thresholds. Determining the pest population levels that justify the implementation of control measures is crucial for decision-making. This assessment ensures that interventions are applied only when necessary, optimizing resource use and minimizing costs. Let's discuss how integrating monitoring into integrated pest management, or IPM, enhances pest management strategies. Informed decision-making. Pest monitoring data serves as the foundation for making informed, evidence-based decisions about the most appropriate control strategies to implement. This data ensures that interventions are targeted and effective. Evaluating effectiveness. Continuous monitoring allows for the assessment of how effective control measures are. This ongoing evaluation enables you to make necessary adjustments and refinements to your IPM program, ensuring its success over time. Sustainable practices. Integrating monitoring into IPM supports the adoption of sustainable pest management practices that minimize environmental impact and help preserve natural resources. This approach is essential for promoting long-term agricultural sustainability. By integrating monitoring into your IPM strategies, you can enhance the effectiveness of your pest management efforts while promoting environmental stewardship. Case studies: successful pest monitoring. In this section, we will explore real-world case studies that highlight the success of effective pest monitoring in agriculture. The first case we will look at is the tomato leaf miner control. Early detection of the Asian citrus psyllid, which is the vector of the citrus greening bacterium, allowed growers to implement targeted control measures. This proactive approach prevented widespread crop loss, demonstrating the importance of early monitoring. Next, soybean aphid outbreaks. Continuous monitoring of soybean aphid populations enabled growers to apply biological and chemical controls in a timely manner. As a result, this strategy led to improved yields and reduced pesticide use, showcasing the effectiveness of ongoing monitoring. Lastly, the citrus greening disease. By using pheromone traps to monitor tomato leaf miner populations, growers were able to time insecticide applications precisely. This careful timing minimized crop damage and ensured high-quality produce, underscoring the value of monitoring in pest management. These case studies illustrate how effective pest monitoring can lead to successful pest management outcomes. By adopting these strategies, growers can safeguard their crops and enhance productivity. Let's continue with the next part of our module. The power of pest monitoring. Let's explore the power of pest monitoring in modern agriculture and how it can enhance productivity and sustainability. Proactive approach. Effective pest monitoring involves systematic observation, detection, and documentation of pest populations in agricultural systems. This proactive strategy is a crucial component of integrated pest management, or IPM programs, allowing growers to identify potential pest threats early. Optimized resources. Effective pest monitoring enables growers to make informed decisions about when and how to implement control measures. This optimization not only enhances resource efficiency but also minimizes the environmental impact associated with pesticide use. Lastly, environmental sustainability. The primary goals of pest monitoring include detecting the presence and abundance of pests, identifying the underlying causes of pest outbreaks, and tracking the effectiveness of control strategies over time. This focus on sustainability is vital for promoting long-term agricultural health. By leveraging the power of pest monitoring, growers can enhance their agricultural practices while contributing to environmental sustainability.